All right, homework 13. Let's quickly take a look at some of the items on homework 13. All right, so in here, we are learning about capacitors and inductors. Capacitors and inductors are energy storage devices. They receive energy, they store it, and then they release it back into the circuit at a later point in time. The later point in time depends on the circuit conditions, depends on the amount of energy that's being transferred. So transferring the energy into these components and back into the circuit is known as either charging and discharging of these components. Okay, so in chapter 3, we are learning about the fundamentals of capacitors and inductors, and in chapter 4, we learn about transient analysis, which is the charging and discharging phase of the energy transfer. Okay, sorry, the charging and discharging portion, which means the energy transferring portion. Okay, so that's transient analysis. But in chapter 3, it's the fundamentals. And so many of these questions are short answer questions. And if you look through the lecture videos and if you recall from your physics classes, you should be able to answer most of them. I cover this point in the lecture slides. Anyone taken a crack at this yet? Okay, any questions? Okay. Three 3.23. Let's see, there's a problem. Capacitors and inductors can also be added up. So similar to resistors, where we try to find Req, and we sum up the resistors in series, and we sum up the reciprocals of the resistors in parallel. So inductors are summed up the same way. However, capacitors are the exact opposite. Capacitors in parallel are added up, while capacitors in series are added up according to their reciprocals. So that's what that question is asking. And then let's see. Ideal. Again, short answer question. 324 is finding CEQ. And as we just mentioned, capacitors in parallel will add up, and in series will add up the reciprocals. This is based on the capacitance equation. C is equal to epsilon A over D. Okay, 3.11. So right here. Okay. Okay, plotting. So here we have somewhat, well, it's not quite a square wave. There's a break in the middle. But we apply our equations and we obtain the values. And if you look at the x-axis, there are steps of 0.5 milliseconds each. So the system requires a corresponding y-axis coordinate for every point that is shown on the x-axis. So for 0.5, 0.1, 1.52, 2.5, all of those points. Otherwise, it will not accept the answer. It will say it's incorrect or it's missing points. That's all it is. Okay. So with the energy, the question being asked is, would it be like a smooth curve or just joining the points? Is that what you said? Yeah, so it does go kind of like that. Not quite a pyramid, but a two-dimensional trapezoid. Yeah. Yeah, like a trapezium. Yeah, that's what it will look like. Does that answer your question? Okay. So yeah, this one is for the physical construction of a capacitor. C is equal to epsilon A over D. Epsilon is permittivity, so epsilon 0 times epsilon R. And then this one is about the voltage and current through a capacitor. So the current is provided. I is equal to C times dV over dt. We are required to find the voltage. So voltage is integral of the current. So 1 over C integral of IC. Okay, if you have not yet taken a look at the lecture videos, please go ahead and do so, and then get started on this homework. This homework and the one after this one, they are, well, lengthy in the sense that there are multiple questions in there, but each of those questions, several of these questions are like multiple choice. So it doesn't take too long to get through these. Then let's see, there was 31, 41, 45, and 61. Those were inductors. 31, already looked at. Inductors. Oh. And many of these are fundamental, straightforward questions, so you should be able to answer them simply by going through the lecture videos. Here, current is given. You're asked to find the voltage, so simply L di over dt. So you take the derivative, time rate derivative of the current waveform that's shown here, and you'd be able to find the voltage. And then power and energy. Inductances are combined in series and parallel, similar to the way of resistors. We already looked at this. And this one is, okay, we already looked at this one too, 331. Okay. That was 361. Okay. So all in all, it's rather straightforward. There's no other, it's a mix of physical construction of devices, short answer questions, and then one problem each for capacitor and inductor, the relationship between the voltage, current, power, and energy. Okay. So if you have time today, review the lecture videos, send the material, and start doing at least some of the problems in the homework. If you have any questions, you can bring them to class on Wednesday. And then from that point on, we'll move on to transient analysis. All right. Okay, so we'll end class here today. Meet up again on Wednesday. If you have any questions in the meantime, feel free to stop by or send me an email. Okay. All right.